So welcome, my dears, for another example of the simple annuity. Here we have, you can see here, we have a simple annuity. We need the future value. Future value means the sum of the amount after a particular time. As example, payment of $1,000 each are made at the end of each year for 4 years. At the end, that means it's ordinary annuity. We have the percentage, the rate of percent, the interest is 6% annually. Everything is fine here. So for 4 years, so the rate is annually, and the years, we have 4 annuities. So we'll say the amount, the principal, multiplied by the principal is 1,000, which is the amount of the annuity. It's 1,000 and it's similar. Then multiply by 1 plus the interest rate, which is 6%. So all will be 1.06. That's power, the number of the years, power 4, minus 1, the one is constant, again divided by the interest rate, which is 0.06, like this way. Once we did it, we will multiply 1.06 power 4, then divide one of it, then the outcome will divide it by 0.06. That will give me a number. I will multiply it by 1,000. That will give me the output, which is 4374.62. Okay, so if we say we have deposits of 1,000, 1,000, 1,000, 1,000, 4,000, but the sum is 4,374.62. That means that the interest which the depositor gets at the end of the period is $374.62. That was about regarding the future value. What about the present value? Present value. Present value is like this. We say the present value will equal the sum of the amount, or the amount which is deposited, the annuity which is deposited, multiplied by 1 minus 1 plus interest, power minus n, divided by the interest back. So it will be the amount. So the interest rate for the interval, and the number of interest conversion intervals, how many times I went to the bank, how many times I deposit. This is the n, and so on. So let's see here as example. Example of the present value. The compound interest is 6% annual, and the annual year end payment is $100. So I'm paying at the end of every year $100. $100. So here, the first year 100 multiplied by 1 plus 0.06, which would be 1.06, power minus 1, plus the second one, power minus 2. Third one, I want the values of these amounts right now here, the PV, the present value. For that reason, it's with negative signal. But I can use, instead of using this way, the amounts like this, I can use almost, as long as the annuities are similar. The annuities here are similar: $100, $100, $100, $100, and the interest rate does not change, which is 6%. And we have amount of 4 years. So amount in payment is 4 years. So the last, at the end of the first year, at the end of the second year, at the end of the third year, at the end of the fourth year. That means that we have simple ordinary. Ordinary means at the end of the period. So here I can apply directly, go to the formula directly and apply this formula, which is telling me that the present value would equal the amount of the annuity, which is $100. Here in the example, it was $100, multiplied by 1 minus 1 plus the interest rate. So 1 plus the interest rate would be 1.06. Power minus 4 divided by the interest rate again. That will equal $346.51. If you want in the present value application, sometimes we had, like as example, if you bought a house and you paid a down payment 10%, 20% of this, the value of this house, then you will pay the mortgage, as example, on 20 or 25 years, you have to pay a mortgage. So if you want to see what are the values of these amounts right now, same thing we do here. So like, let's see this example is very nice. Let's say this example. I guess we can take it. Here we go. I just want to enlarge this and take this up to the top like this. Here we get this one here like this way. Then increase the volume so that everyone can see it. Avocation, like we say here, avocation property is bought for 3,000 down payment. Cool. 3,000 down payment. So we'll pay 3,000 down payment. Okay. And what? And let's see here, get the payment of $1,000 at the end of each 6 months for 12 years. So twice a year. That means twice a year. In 12 years, that means N will equal 24. N will equal, again, we paid at the end of each 6 months, means it's ordinary because it's after each 6 months you have to pay. So in 1 year you pay twice. So in 20 years, how much you pay? 24 times. Okay. And the interest rates, here we go to the interest rate. Let us go to the interest rate. The interest rate here, let us take, I just want to drag it a little bit down here. So the interest rate is 7% compounded semi-annually. 7% semi-annually. It's in the annual 7%. So semi-annually means that you will divide 7% by 2. You will divide 7% by 2. So it is like it's the whole year, it's 7%. But you have to do it semi-annually because you calculate everything here semi-annually. So if it is 7% in the whole year, how much it will be in the every 6 months? How much it will be every 6 months? So it's the opposite now. So we'll say 7% divided by 2. Okay, 7% divided by 2. So that will give me 3.5%. 3.5%, it takes this figure. Because if I say 3.5%, let me show it to you. If I say 3.5% as example here, 3.5%. When we say it like this, when we calculate it like this, it will be 0.035. That is how it looks like. So actually, what happened here, that the 7%, we divided by /2, that will give me this amount. The meaning that it takes 7% for the whole year, but we want how much every 6 months then? How much every 6 months? That's what we want. So it's 3.5% every 6 months. Because why we did all this? Why we converted into 6 months? Actually, to be honest, we did this for every 6 months because all the calculations here are for the 6 months. So it will be 0.35, and the number, the N, would be how many? Every 6 months you go and pay the mortgage every 6 months. So you do it twice a year. So in the 12 years, they are 24 times. So now how we will get the cash or the present value will equal 3000 plus we'll finish this 1000 multiply by 1 minus 1 plus the interest rate power minus 24, which is the n or the numbers of the installments, number for mortgage, so on, divided again by 0.35. So here this 3000 plus this amount. So all this amount right now equals $19,058.37. Same examples, or also we can go to another examples like it's the same idea. So it's the same idea of these examples as well. That was for the moment. Thank you so much. We'll go for another video right now. Thanks.